Calculus, Unit 7, Day 64, Part 2. So there's a quick question. I kind of went over it, but just to make sure we're all on the same page. What do you notice about the integral defined formulas for finding the volume of solids with certain cross sections? So square, isosceles right triangle, equilateral triangle, semicircle are all identical. The square just doesn't have any factor being multiplied by it. So that's just 1. The isosceles right triangle is 1/2. Equilateral triangle is square root of 3 over 4, and the semicircle is pi over 8. Okay? But everything else, if you can just think of a square, hey, it's going to be the outer function minus the inner function. That's going to be the length of one side. That's the f of x minus g of x, and it's side squared. And then all of these are exactly the same except for these factors. Can you think of a right triangle? Like we're talking about isosceles right triangle, excuse me. So like what's the relationship between the 30-degree side to the hypotenuse is 1 to 2, so that's a way to remember that. These last two are a little bit different, but again, um, 1, 2, 3, 4, and then pi 8. But um, the more and more we use these, the easier it will be to remember. All right, so let's look at this last part. So region R is bounded by y equals sine of pi x, and that's going to be this function right here. Put that in blue. And also region R bounded by the cubic function x cubed minus 4x right here. So there it is, all shaded in. So find the volumes of solids formed whose cross sections are the shape indicated below. The cross sections are perpendicular to the x-axis. Okay, so they're all perpendicular, so they're all going, so those, whatever it might be here, and then you build up a square, build up a semicircle, whatever. So this is what they mean by perpendicular to the x-axis. Again, that's really an infinite. I drew a little bit wider over here. Okay, and so we're going to call, if going back to our other formulas, I'm going to call sine of pi x f of x and x cubed minus 4x g of x. Okay, so when they want to know when it's equilateral triangles, all right, I know that. So volume equals square root of 3 over 4, and we're going from 0 to 2. And it's f of x minus g of x all squared. So sine of pi x minus x cubed plus 4x all squared dx. So some of these we could do up by hand. This one I could do right on the calculator. I'm not sure if I can get that to come up, but maybe at the end I'll show this one on the calculator. But A, B, C, and D we could all do on the calculator. Okay, so try that. Okay, and then we also got semicircles, which is just going to be pi over 8 out front. And then for part C, we're dealing with isosceles right triangles, which is everything that we just did, except this is 1/2 integral from 0 to 2. And then the last one, squares, again, we don't need to write the 1, but it's f of x minus g of x, and we have those functions. So let's write these two in. Okay, so here's our solutions, and we'll go back in a little bit, and I'll do a part 3, and we'll do those on the calculator. But I also forgot the squares are up here. So again, these are all squared. That was squared, but you can't really see it. So those are our answers. Hopefully you got all those. And let's look. They just tweak it up a little bit for part E and F. They take what we know and then they just change one of the sides. So let's see if we can draw ourselves a picture and set these up. Okay, so this one's a rectangle whose height is twice the length. So here's my length, which we still know is going to be f of x minus g of x, what was taken from the squares, and now the height is twice this, so 2 times the quantity f of x minus g of x. So the area is going to be length times width, or base times height in this case. Those are the words they use. And let's write that down. So the area equals 2 times f of x minus g of x all squared, which is twice whatever the square would have been. And now how do I find the volume? Well, that's 2 times from 0 to 2 of what we had for the square, fx minus g of x, all squared dx, and now with the functions I have, I can put that into the calculator and get 19.957. So I'll show you how to, once we get the set up, how easy that is to put in the calculator. Okay, and this one, cross sections are rectangles whose height is 1/3. So this is fx minus g of x, and this is going to be 1/3 fx minus g of x. I'm not going to be able to see that. So let's set this up the same way. Area equals 1/3 fx minus g of x all squared. Instead of 2 times it, and now the volume is going to be equal to 1/3. Make sure that's 1/3. The integral from 0 to 2 of fx minus g of x all squared dx. And now when we put that into the calculator, 3.326. Okay, and again, what functions are we using? The two functions that were given up here. All right, and I'm going to put those in my calculators, y1 and y2. All right, so that'll be part 3.